My name is Isa Muhammad Zumo. The title of my presentation is Mapping Seasonal Variations of Grazing Land Above Ground Biomass with Sentinel-2A Satellite Data. The paper ID is 145. The presentation outlines goes as follows. The first is the introduction, where I will talk about the background of this paper, the previous literatures I reviewed, the problems this paper is trying to address, the research objectives, and the scope of this my presentation. The materials and method will center on the study area first, then the satellite data I use, as well as the ancillary data, and then the methods I adopted. The results, I will talk about the spectral transformation models results, then how I validate those spectral transformation models, and then the estimated gap I get, and then the grass above ground biomass relationship with temperature and rainfall. Then I will discuss on the gap estimation from satellite data, effect of seasonal variation on livestock production. Then I will see how this paper will scientifically address the grazing land complexities. Then also I will see how this paper will contribute in United Nations Sustainability Development Goals Target 2, that is food security. The introduction. Globally, grazing lands are facing a significant warming and drying processes, more especially in the Sahel regions of the savannah. There are so many literatures that were conducted on grasses or grazing lands, but actually there are limitations. And some of the limitations are using satellite remote sensing in obtaining the grass above ground biomass, that is the quantity of grass in the grazing land. There are so many complexities that our grazing lands are facing that were caused by the variations in rainfall and temperature. Now the question is, how can we address those complexities scientifically? Therefore, the objective of this my presentation or of this paper is to map and model monthly grass above ground biomass variations to their corresponding meteorological data with satellite data. However, this paper is within the scope of using Sentinel-2A multispectral imagery data and meteorological data of YOLA for the year 2018. The materials and method. The study area is the study area. The study area is Dawari grazing land, and it is in Adamawa State, northeastern part of Nigeria. The materials I will use here were categorized into three. The first is the satellite imagery. The second is the in situ data, and the third is the rainfall and temperature, that is the meteorological data of the study area. The method I will adopt is as follows. First of all, I will get in situ data, that is of two categories. We have the induction dataset as well as the deduction datasets. The deduction dataset now, along with the vegetation indices that was derived from the satellite data, will be modeled using machine learning algorithms to generate satellite transformation model. Those models that were generated will be selected based on their R square at least should be 0.8, a little less or a little more. Now those models that were selected, they will equally be validated using the deduction datasets. Now the validation will be the deduction datasets will be combined with the gap derived from those models, and their root mean square between the two gaps should be less than 5 grams per meter square. Once any model that attains this accuracy will be used for calculating the entire grazing land grass above ground biomass. Now from this paper, the results I get, 4 indices was used which was considered best for modeling, and these are their corresponding models. Out of these four, the vegetation index number is having a higher R-square value of 0.87. And now this was selected therefore, and it was validated with the deduction datasets, and the results obtained between the model gap as well as the deduction gap, the root mean square between the two data is 1.75 grams per meter square. Therefore, the wind model was selected to compute the grass above grass biomass from January to December, that is monthly, of the entire grazing land. The grazing land has a maximum gap estimated at 7,353.55 tons of grass by the month of September. Approximately, that is 1.02 tons per hectare. The minimum grass availability is in the month of February, estimated at 24.65 tons, approximately 0.32 tons per hectare. And even from here, you can see by the month of September, we are having the highest gap, which is this one. And the minimum is actually February, very, very small. This paper also see now the relationship between temperature as well as rainfall within the rainy season. And the rainy season is of 6 months. Now it can be seen from the relationship, the grass above grass biomass within the rainy season of 6 months along with rainfall is directly proportional, while in the temperature it is inversely proportional. That means the more we have rainfall, the more grasses grow. The more we have temperature, the less we have grasses. In the discussion, the relationship between simple ratio vegetation indices with vegetation parameter under investigation. Here, the vegetation parameter here under investigation is the quantity of grass in grams or in kilograms or in tons. That is the grass above ground biomass. Some authors may use maybe the grass height or the grass thickness. But here is the quantity of grass, that is the grass above ground biomass. We'll give a suitable model for vegetation studies. This agrees with previous researchers like Issa et al., Oliveros et al., Issa et al. Such studies as this paper contributes for systematic evaluation of grazing land complexities that was caused by seasonal variations in rainfall and temperature. Both man-made and natural disasters such as drought, famine, mass migration, flooding will be minimized by providing spatial temporal information that is monthly basis, especially for policy guidelines into local and regional planning regarding the restoration and sustainable grazing lands. These are the natural disasters. Some are man-made, some are natural, that was caused by seasonal variations of rainfall and temperature. It may cause bush burning. So many grasses will burn. So many livestock will die. This no grass, no water, so livestock will definitely die. And there will be mass migration now. These people, they are herders, they are nomads. So their business is to rear cattle. Every time they have to be looking where is grass, where is water. Now here there will be shortage of water. They have to be digging well to be feeding the cows. So these are major problems that these seasonal variations will cause. And this study, at least the usage of this study by providing spatial temporal information of the quantity of grass in the grazing area will contribute in addressing these problems. In conclusion, this paper demonstrates that the grass biomass can be estimated monthly in relation to variation in rainfall and temperature, and thus provides grass availability periods in the grazing land. The study will also contribute in achieving the United Nations Sustainability Development Goals, set target 2, that is food security and sustainable agriculture, as well as target 13, that is climate action. Thank you for listening.